Hi, my name is Michael Trungles. I'm a junior at Concord High School in Dr. Estock's Engineering Level 3 class. My client is Mr. Runyon, a social studies teacher also at Concord High School. I connected to him via my engineering class, where he reached out to have a project made for him. Mr. Runyon leads a Boy Scout camp in the Adirondack Mountains in New York. The laws there require that the toilet covers in outhouses are covered when not in use for hygienic purposes. However, the kids do not close them after use. Mr. Runyon wanted a device that would close the covers automatically. The device had to be purely mechanical, because electronics would not survive in the strong conditions that could appear at that camp. There could be rain, there could be snow, mud, so it had to be purely mechanical because electronics wouldn't hold up. It needed to not interfere with the camper's use of the toilet, because that might cause them to want to break it. It also had to be reasonably cost effective, because you may need multiple devices built. It also should be easy to install and be made out of easily replaceable parts and materials such as wood or rope. One solution the client already attempted was using bungee cords to hold the cover down. This was problematic because the lid would press onto your back when sitting down, which was both unhygienic and annoying, and cause the campers to cut the bungees. This really showed the importance of this device being non-invasive, because if it interferes with them, they will try to break it. These were some of my early designs. A common theme was a board that would be stood on, which would activate the device, and the lid either being pulled closed by a rope or hit closed by something from the back. These ideas would all eventually work together in the final design. However, my first prototype only involved it being pulled closed. While the prototype worked after much time adjusting it, it was too unstable and too unreliable. I decided that pulling the lid closed would not work well enough. So I switched my design to now involve hitting it down from behind. This was both more reliable than pulling it with the rope, and also removed the issue I was having where it might accidentally close unintentionally. I was able to keep the board and rope from the previous design. However, now, instead of pulling the lid closed directly, they were used to wind up this hammer in the back that would then hit it closed. I was also able to still use the part I designed and 3D printed shown here. This was a guide that kept the springs nice and stable. All my time and effort came together to form this, my final working design. As you can see, the weight behind the hammer is adjustable. Currently using a dumbbell, however this can be changed on the spot. This device will allow my client to know that his camp is keeping with the law this summer, and that the outhouses are staying hygienic